Hey everybody, today we will do another video. It's going to be mathematics related. And we are doing what is called the Laplace transform. Laplace Laplace transform. Okay, so we're doing what is called the inverse Laplace transforms, and this stuff, some people write it one word. It doesn't matter. Doesn't matter. So what we're doing, we do the inverse type. Inverse Laplace transform. So basically what is going on here is like we have a function, we have Laplace transform of a function, right, of some function f of t, right, that it was taken the Laplace transform, and that function is equal to big F of S. So in other words, they went from one domain to another domain. This is called time domain. This is called the Laplace domain or the S domain. And this S, to be just, I don't want to go through too much, but this S can be a complex number, can be a S, can be a complex number, or a real number. So it can be both, right? So the S right here, it can be a complex number or a real number. Okay, so with that being said, let's get started. So now, for us, we're going from this back to this. That's our goal, right? So we will be doing a problem that is, it said that f of s, which is capital S, right, is going to be s plus 8 over s plus 1 times s plus 7. Okay, so now you notice that, so the rule that we need to understand in this is the following. So if we have a polynomial in the bottom, which in this case we do, we have two factors, right? So we have a two factor, we have a polynomial in the bottom, and it's greater than the polynomial at the top. That is actually a what is called a it's a degree higher, right? Because if you multiply this times this, it's going to be an x squared, right? So it's a degree higher than the top, which means that at the end we will have a letter, we have something like this. So we have some number. This is going to be multiplied by e to the st, negative st, right? And back in, I think I got a in my channel, I think I got a video explaining about why that's negative. Because what happened is when this goes to infinity, this actually converges either to 1 or 0, right? And that is the whole purpose of it. So now, but I don't want to talk too much about this because that's something that really, so let's get it started. Let's get started with the problem, right? So there is 2 methods to do this, and because we only doing one problem, I will do the 2 methods. It's not really difficult. So the first method is going to be the following. It's going to be finding the coefficient of these terms, right? And the second method is going to be, it's called the residue method, right? So the first method is called partial partial fraction. Partial fraction decomposition. Partial fraction decomposition, that's the first method. It's a little more complicated, but at least you get more understanding. I think by doing it that method, you get more practice in mathematics. You actually have a bit. I think you have a better understanding of the problem. Okay, so by doing this, we do the following. So we have this, right? So this is equal to that, right? So I need to find the time domain of this. This is a basic Laplace domain, right? Now what I can do is going back, right? I need to reverse this. Find the inverse. Okay, so to find the inverse, we do like this. So it's a little L like this. This is the Laplace, and this L actually. So this L like this. It's kind of goofy. L like this, right? This is so I'm taking the inverse of this, which is s plus 8 over s plus 1 times s plus 7. Okay, so taking the inverse of this, right? So that's what we're doing. So now what we can do here is the following. So we can break this down into the following. So we can say s plus 8 over s plus 1 times s plus 7, right? Equal to what? Okay, so equal to something. is equal to something, but that something is going to be this denominator, right? So it's going to be equal to A and B, which is going to be A plus, it's going to be a plus, B, right? And then this is going to be like this. So it's going to be S plus 1, and then S plus 7, right? So now, my goal is the following. My goal is to find A and B. Now, how we do that? Well, we do the following. So right here, I'm going to, so S plus 8 times S plus 1, divided by S plus 1, and multiply that by S plus 7, right? And it's going to be equal to this side and the other side, right? But there is a reason why I'm writing this, right? I don't want to skip any steps. I want to make sure that you guys understand what I'm doing. So now, what this is doing is, actually I'm taking a copy of the denominators to the other side, right? So now what I'm doing is A, right? So it's A over S plus 1 plus B over S plus 7. Now, notice that I need to get rid of these guys, right? And also I need to get rid of these guys. I need to solve for A and B. How do I solve for A and B? So what I'm going to do is the following. So I'm going to multiply by this, and this, right? So this guy get multiplied, right? The whole purpose of this is the following. So you will understand what I'm doing right here. So the denominator goes on the top right here, and I said S plus 1 times S plus 7, right? And here, same thing. I said S plus 1 times S plus 7, right? And S plus 1 times S plus 7. Notice that these guys cancel out. This is gone now. That is gone. Now, here you should put parentheses around, which helps, right? Now, this guy, go with this, cancels out. That one is gone. And then this one and this one also is gone, right? Now, let's look. We have now. Let's look what we have, right? So now we said S plus 8, S plus 8, S plus 8 equal to this multiplying that guy is going to be S, right? It's going to be AX plus 7, right? A. Right? So now I multiply, and then I do B. B times this, right? So it's going to be BS plus B. BS, not BX. It's BS plus B. Okay. So now, notice that what I am trying to match, whatever I have over here, whatever I have in the left, I have in the right. I am trying to get the coefficient. That's why this method is called partial fraction decomposition. I am decomposing the fractions to find some value for A and B. So A and B, right? Notice that over here I have an S, and I have an S right here, right? So I can say that S, oops, so S, right? This S is equal to this 2 guy that has an S on it, which is AS plus BS, right? Now, S is equal to, you can A plus B, factoring out the S outside, and you divide that guy, and you get that 1 is equal to A plus B. Now, I have one equation, right, with 1 in this side, which is a number much better. Now what I can do is, this is gone, that is gone, and that is gone, right? Now I have only this, and this, right? So now what I do? Well, same thing. So what I can do right now, right here, hold on, let me just do it right here, right? What I can do right now is equate this one that is equal to this 2 constants, which makes sense, right? So it's going to be 8. 8 is equal to 7A plus B. Okay, so now, if you think about it now, right? So, okay, so now we have an equation that looks, they can be solved, right? 2 equations, not bad. Okay, so now we have that. Okay, so now that we have this equation, and that equation, right? Now let's do this. So let's do A plus B equal to 1, and let's do 7A plus B equal 8. Okay. Again, now let's go back to little high school math, right? Or maybe middle school, I guess high school, right? Solving problems. We need to go back to the basic again, which is, I think it's pretty cool. I mean, there's nothing wrong going back to the basic, as long as, if you learn something, you can go back to it, right? That's why you gotta have just those tools in your toolbox. When you use them, when there is a time to use them, you just go over there, open the toolbox and get the tools out of there, right? It kind of makes sense, I guess. Okay, so now let's look at this. So I have a system of equations now. I got a system of equations of 2 variables per equation. But obviously I cannot do this, and I cannot just combine these 2, right? I need to do something, right? I need to get rid of one of them so I can solve it. By doing this, so I can actually multiply the top equation by -1. If I multiply the top equation by -1, this will make this guy a negative, and this negative with that positive will be gone, and I will just add the A's, right? Once I add the A's, I will have a number over here, and then if I have a number over here, I am good, right? So that's the whole purpose of it. So negative multiplied by a negative top, right? Left and right. So what we get? So we get negative A minus B equal to what? Equal to -1, right? Easy? And then we do 7A, right? Then we do 7/8, right? Right here we do 7/8, and then we do plus B equal to 8. Regular 8, right? Now let's do this. So let's cancel those guys out, right? And let's add this 2. So that 8 plus 7a is equal to 6. It's equal to 6a, right? And then that is equal to a 7, right? Now I am done, pretty much. So divided by 6. Alright? Guess what? A is equal to 7 over 6. Okay, so I got the first one. Now I can go back and get one of the original equations. I can get go back of the original equation and solve for b, and I am done. Right? Easy. Now, let's get this done. Right? So now I get this value, right? So I take this over here and let me use that one. So a plus b equal 1, right? Okay, so now if this is equal to 7, so it could be 7 over 6 plus b is equal to 1. Subtract this on both sides, and I get a b equal to 1 minus 7, 6. Okay? So you can say, oh, it's an improper fraction. Oh yeah, it's an improper fraction. We don't dealing with that stuff right now. We can actually just, right? So now we have the b is equal to, subtracting this one and this side, right? I subtract this one, move it to the other side, subtract it to the other side, I get this, right? I guess it's confusing, maybe not. I mean, I can do it step by step. I can actually say, okay, subtract 7, 6, subtract 7, 6, right? And then b equal to 1 minus 7, 6, right? But I'm not done yet at that point, right? I need to find the common denominator of this. Okay, so for that, so when I do the common denominator of this is going to be 6 over 6 minus 7 over 6. Right? So now 6 over 6, now adding those two, right? B is equal to negative 1, 6. That's B. B is negative 1, 6. Now, that is just the mathematics part of it, right? Now we need to transfer that guy into the inverse Laplace. Now that just basically tells me that I found the A and B. Now I have to say, okay, so A, the Laplace, the inverse Laplace, right? Inverse Laplace, right? Of this guy, right? Of inverse Laplace of f of x, right? Right? So, inverse Laplace of this that was given to me, I need to turn it into the time domain, right? So what I need to do? Well, A, right? This is, whatever is in this, it is the opposite that is going to go in the T. So in this case, this is a T right here. It's a positive T. It's a positive T, which S is going to be equal to a negative T in it when I turn that into with it when I multiply it by the Euler's number, right? So, but anyway, let me just do it like this right now. So, okay, so let's do this. So A was 7 over 6, right? Right, and then E, right? What is my E? My E is, it's going to be the one that corresponds to this, right? But remember that this was, okay, so this is S plus 1 over here at the bottom, right? And this is the value of A. This is the value of A. But A is to the, some people do E to the AT, right? Negative AT, right? That's fine. Because, okay, so in this case, it's negative T on the top. Okay? So negative T. When I do the negative T, and this is, but in reality, okay, so let me just go back, because this is kind of, I kind of skip a step over here, but technically what is this. So A, okay, so this is A, this is B, right? So, okay, so this is what is going on right here. So this 7 over what? Over this guy, over 1 over S plus 1 plus, so it's actually 7 over 6 over S plus 1 plus 1 negative plus, and then a negative 1, negative 1/6 over S plus 7, right? That's what I have. Now, that's what I'm writing right here. This is what I'm writing down right here, except that I'm adding the E. So E, so now let's do minus, right? Minus what? Minus 1 over 6, right? Over S plus 7, and then E to the minus what? Minus 7T. Now, I use this only to find out what is below at the bottom. But technically, I don't need them. So what I can do is bring this to the front, right? Bring this guy to the front and leave the E's on the top. Okay, so let's do that. So I just did that just to see what is in the bottom. If I have a negative 1, this negative 1 goes on the front of the T. If I have a negative 7, plus 7 over here, then minus 7 goes on the top on the top, right? Multiplying that T. Okay, so now what I can do is bring those down, right? So in this case, it's simply bringing those down, right? Bringing those down, and I get what I have, right? So just like that, right? So now what is going on here? So you see what I can do? I can factor out 1/6, and I can leave 7 inside E to the T minus E to the 7t, right? Right? That and that I can factor out 1/6 out, right? And that is this guy right here. That is the inverse of that. So this is the inverse Laplace transform. So inverse Laplace transform is the following. So is 1/6 times 7e to the t minus e to the 7t. That is the inverse Laplace, right? So this is the inverse Laplace transform, which is, I don't know if these markers are not really helping. I mean, it's just, right? So E, right? This is a T, and this is also a T, right? So, and this is also a E, which is, right? So this is actually the Laplace in time domain. So this is now Laplace, right? So I found the inverse of Laplace. So now this now is going back to the time domain. This is the regular, not the inverse, but the regular now. Regular f of t. Right? Okay, so now that's basically Laplace transform in time domain. Now let's do the other method, which is easy, very easy. But I think I like to do it this way because I practice a little bit of algebra and all that stuff, which is good. The other one, the other method is called the residue method. Right? So in the residue method, what is basically I am doing is the same thing. Find A and B with now the difference. I don't have to do all this. So what I can do is just do it like this. So A equal to, okay, so the problem was 8 was S plus 8 over S plus 1, right? And S plus 7. That was the problem, right? So now I can say that A is equal to this, right? So A is equal to this. So the residue method, what I want to do in the residue method is I want to cancel this, cancel that by multiplying it over here and keeping this. Cancel this guy by multiplying the numerator of the expression, and then by multiplying that, right? So I will get rid of this, and then but I will send this. I will make that equal to 0. So make this guy equal to 0. That is the whole purpose of it. Now, once I find what S is by sending this equal to 0, then I can actually plug it in for every single value of S, plug in the value of the number that I found out over here, right? So, okay, let's do it. So, okay, so let's do this. So now let's do this. Let's do S plus 1, right? Now the Laplace that I have this, right? So S of S, right? Because I have this expression which is given to me in the Laplace domain, so I need to find A, right? So what is the method? The method for A is the following. So B, okay, so what is going to be B? B is going to be that one, right? So B is going to be equal to what? Is equal to S plus 7 and the of the Laplace domain of that, right? Now let's do this. Okay, so to find A, what do I do? A is going to be equal to 7 it's going to be equal to S plus 1, right? S plus 1 times this guy with this, the whole thing, the Fs is represent that guy, right? And then, so times S plus 8, right? All over S plus 1 times S plus 7. Now, what do I do? Let equal this guy. S plus 1 equal to 0. S plus 1 is equal to 0, then S is equal to negative 1, isn't it? Right here. Now look at this. This guy cancel out with this, right? So now A is equal to the following. So A is going to be equal to S plus 8. S plus 8 over 7 over S plus 7, sorry. S plus 7. When S equal negative 1. Let's plot negative 1 for S. And I get that 1, negative 1 plus 8 over negative 1 plus 7, which is equal to 7 over 6, isn't it? Is it not the same thing that we had? Right? Same thing we had. Right? When we did the other methods, much easier, right? Now the same thing we can do to find B, right? So B now is going to be the following. So B is equal to this guy, right? Multiplying Fs, right? So Fs is what? It's the whole thing, right? That is Fs right here. Now let's get it done. So now B is equal to what? It's equal to that guy, S plus 7, S plus 7 times S plus 8 over S plus 1 times S plus 7, right? Now notice that this S plus 7 with this is gone, right? What do I have? I have S plus 8 over S plus 1, right? So I got S plus 8 over S plus 1. Now in this case, what was my S over here? So S equal S plus 7 equal to 0. S is equal to negative 7, isn't it? Now this is very hard to see right here. This is not good. So it's S plus 8, right, over S plus 1 over S plus 1, right? When s goes to -7, right? Once I do that, okay, so now I do the same thing, right? So right here, I do the following. So I do -7 plus 8. -7 plus 8 over -7 plus what? Plus 1. Okay, so -7, right? That the top number is what? It's positive 1. The bottom one is -6, right? So right here in this case is b is equal to 1 over -6, which is technically is negative, okay, negative, like that, -1/6. As you can see, I got the same values. Now all you gotta do is do the same thing, right? Do the substitution right here and multiply it by e is in factor out 1/6. It's the same answer, exactly the same answer. So the value for a and b we found using the two different methods, the residue method and the partial fraction decomposition. We're able to find the same values for a and b, right? So that's the answer for that problem. And I hope you enjoyed this video. I see you in the next video. Thank you for watching.